Hi guys, welcome to the lesson for April 22nd and 23rd on the quadratic formula. Don't forget that if you have questions, you need to email me at bmcneely@riversidehighschool.org. It's definitely not too late to turn in late work, so make sure that you're working on that and getting that handed in. One plan I would suggest is there are only 2 math lessons per week with Fridays off. So maybe plan on doing your 2 lessons per week, Monday through Thursday, and if you're behind, pick up a third one over the weekend. To set yourself up for success, make sure you have out a pencil and paper and be ready to take notes and try the U-Try problems as we go. I'm getting a lot of emails from people who aren't able to do the IP. That's because you're not logged into your school email address. At this point, everybody should be able to use their riversidehighschool.org email address. You might want to log in first, then try to open up the IP, and that should do it. If you have any questions, just email me with that, and I can help you get yours set up. I want to do a quick lesson today about email etiquette and using the subject line. The subject line of an email should be used only for 3 to 4 words that give a few details about what the email is about. So your subject goes right here. You could put hello if you just wanted to say hi, or you could put missing assignments. You could say that you need to talk about the IP from 419 and 420. You can say, like we said, we could say hello if you just wanted to give a quick message, or you could say that you wanted to talk about office hours. Whole sentences should not go in the subject line. This should only give me a brief piece of information about what you're going to talk about. So let's say that you wanted to talk about office hours. That's what goes in your subject line. Then this is called the body of the email. We'll talk more about appropriate emails to a teacher or professor next time. But for now, know that any other further messages or sentences should go down here. I'm going to start asking you to rewrite the emails that you send me if they're not following this format. Struggles or celebrations. My celebration this week is that my husband and I took Brody on a walk. We parked in front of the school and walked down the trail at Riverside Park. While we were at school, I stopped to grab this yard sign for our yard. There are plenty of extras available. You could have one too. Just swing by during lunch pickup. You can have a no contact pickup of your new yard sign to put out in your yard. Right now, pause this video and complete the bell work below. Remember, it's really important to keep practicing these problems so that you don't forget everything while we're gone. I'll go over the solutions if you get stuck. In order to simplify, remember we're looking for perfect squares. 125 is not a perfect square. In order to find the missing perfect squares, I have to do a tree. So 125 divided by 5, we're going to put that right into our calculator, and we get 25 for that. And 25 is also 5 times 5. Remember that pairs are squares. There is one pair of 5s that goes on the outside of the radical, and anything that's a single goes on the inside of the radical. We can do the same thing with 28. 28 is not a perfect square. 28 turns into 14, or excuse me, 2 times 14. 14 is 2 times 7. The pairs are the perfect squares. The pair of 2's goes on the outside. The single 7 that's left over goes on the inside. All right, for this one, you're going to estimate with a calculator. So everybody should find the square root button on their calculator. It looks like this, kind of like a divide sign. For some of you, it's over or near the x squared button. For me, I have to push the second button on my calculator. So I'm going to hit second square root, and then I'm going to put in the number and hit enter. And what I get for that is 5.477 2, dot, 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 dot. This says round to the nearest tenth. Well, the 4 is in the nearest tenths place. We look to the right. The 7 will tell me whether to round up or stay the same. In this case, anything that this number is higher than 4, so it's telling me to round the tenths place up to 5.5. We're going to do the same thing for 77. I'm going to hit second square root of 77 and hit enter. I get 8.77496 dot, dot, dot. That's the tenths place. I look to the right. The 7 tells me to round up, so that turns into 8.8. Nice job. Our lesson for today is called the quadratic formula. By the end of this lesson, you want to be able to solve a quadratic equation using the quadratic formula. We already learned last time how to solve a quadratic equation by factoring. We found the zeros. If you haven't done that yet, you need to stop this video and go back and do the previous 2 lessons. When we solve a quadratic equation, remember this is what we call standard form, ax squared plus bx plus c is equal to 0. What we're actually finding are the x-intercepts, or the zeros, of the parabola. The number of zeros gives us some information about the parabola. If I get 2 answers, for example, on this one, my answers would have been x equals -2 and x equals 3. So when you were solving these last time, what you were actually finding was where the curve crosses the x-axis. For this one, there were 2 zeros at x equals -2 and x equals -3. It crosses that x-axis twice, so there are 2 answers. That's why when you were solving these last time, we learned that many times there's 2 answers. Sometimes when we factor, we get the same factors. You got something like x minus 4 times x minus 4 equals 0, and so you would just have one answer, that x equals 4. What that means is the vertex of our curve is touching our x-axis. In this case, there's just one answer, x is equal to -3. In this case, there's just one answer, x is equal to 1. It crosses the x-axis at -3 on this graph and crosses the x-axis at 1 on this graph. But sometimes what we will find is there are no solutions. That's what we're going to be working on today. What happens when we can't find a solution? What that means is we have kind of what we call a floating curve. The vertex and the parabola, neither one touch this x-axis. The parabola itself never touches the x-axis, which is why there's no solution there. Right now, pause the video and you tell me, how many zeros does each parabola have? How many times does each parabola cross the x-axis? Welcome back. Right here are all the places where the parabola crosses the x-axis. In this case, it crosses the x-axis at x equal to -2. So there is 1 0 here. In this case, it doesn't cross it at all. There is no solution. So what that means is there are no zeros. And in this case, it crosses twice at x equals -2 and what looks like about 1/2. And so in this case, you would say that there are 2 zeros. We're counting the number of times the blue curve crosses the x-axis. Notice we're not focused on the y-axis right now. So what you would have done last time is you would have found the zeros by starting off putting this in standard form. Essentially what we're doing is making our y equal to 0. Remember when we found the y-intercept? And what we found was we could find the, I should have said the x-intercept. We could find the x-intercept by replacing y with 0, which is what we are doing here. We are making this equal to 0. And then you were supposed to factor. So step 2 was to factor. So a times c became 1, and we're looking for 2 numbers that multiply to be 1 and add to be -3. Well, 1 and 1 don't work. -1 and -1 don't work. This is not factorable. That means that I can't do step 3. This does not mean there's no solution. We have to go one step farther. When a quadratic equation can't be factored, we can use what we call the quadratic formula to find the zeros. So here's some steps here, and you're going to want to write these in your notes. I want you to title this quadratic formula, and I want you to pause the video and write these steps. First of all, your equation must be in standard form, which means it's equal to 0. We worked on that a lot last time. And then you want to be able to identify your A, your B, and your C, which you all have gotten really good at doing. And then there's this big crazy formula that we're substituting into. We're replacing B with whatever B is, replacing A with whatever A is, and replacing C with whatever C is. I do want you to make one adjustment to this formula that'll make your life easier. There tends to be a lot of sign errors when we do the inside of the radical. So I want you to replace your minus with plus a -4 times A times C over 2A. This will be the formula that you'll see me use, not this. even though they do the exact same thing. So let's try this. It says find the zeros of the parabola. So what that means is this makes some shape that looks either like that or like that. They want me to find where the parabola crosses the x-axis. They want me to find the zeros. And so my first step is to replace y with 0. So we have x squared minus 3x plus 1 is equal to 0. We already tried to factor this and it wasn't factorable, but we can still identify our a, our b, and our c. A is 1, b is 3, and c is 1. All right, I want you to pause the video and find the mistake that I made in step 2. The mistake that I made in step 2 was b needs to be negative here. That's a negative in front of 3, and that's important. We can't just ignore the signs on our a, our b, and our c. And then we're going to use the quadratic formula to solve. All right, so our quadratic formula is the same every time. You don't have to have it memorized, but I would write it down. It's negative b plus or minus the square root of b squared. Sorry about that. Plus negative 4 times a times c all over 2a. Well, this negative in front of the b is telling you to change the sign of whatever b is. So that's a negative and another negative. And so when I replace b, that actually becomes a positive 3. And then that should have been plus or minus there. Plus or minus the square root of. And then when you substitute in for the b, I would always put your b in parentheses like this. So that becomes negative 3 squared plus negative 4 times whatever a is times whatever c is divided by 2 times a. Oops, I'm sorry. That should have been not a, but 2 times 1. All right, so now we're going to simplify. The hardest part of this for most people is simplifying. Let's simplify what's inside the radical first. So I have 3 plus or minus the square root. Negative 3 squared is negative 3 times negative 3. It is not negative 9, it is positive 9. And then negative 4 times 1 is negative 4. All over 2 times 1, which is 2. Remember we said to simplify what's inside the radical first. So that's 3 plus or minus the square root of 5 all over 2. Now, this is why we practice simplifying with our calculator. 5 is not a perfect square. In order to graph this, I'm going to want to estimate what 5 is. So in my calculator, I'm going to find the square root of 5, which rounds to the nearest tenth as 2.2. So that's 3 plus or minus 2.2 divided by 2. Now, what's this plus or minus mean? Well, remember, we're looking for 2 zeros. This is our clue of how to split this up into 2 problems. It's saying that we could have 3 plus 2.2 divided by 2, or we could have 3 minus 2.2 divided by 2. In this case, we do 3 plus 2.2 and hit enter so that the calculator knows we want to find that first. Then we divide by 2 and we get 2.6. For this one, we do 3 minus 2.2, we hit enter, we divide by 2, and we get 0.4. So my x-intercept and y-intercept, or excuse me, my x-intercepts are 2.6 and 0.4. Those are decimals, which is why we couldn't find them using factoring. I want you to go ahead and stop here. I want you to go back to Haiku and find part 2 of the video for today, and we'll pick up in our notes from there.